Today we are going to discuss IP security services. These are the services at the IP layer by enabling a system to select required security protocols, determine the algorithm to use for the services, and put in place any encrypted keys required to provide the requested services. Two protocols are used to provide security: an authentication protocol designated by the header of the protocol, authentication header, and a combined encryption authentication protocol designated by the format of the packet for the protocol, encapsulating security payload. RFC 4301 is the following services. First one is access control, next one is connectionless integrity, third one is data origin authentication, fourth one is rejection of replied packets, fifth one is confidentiality, and the next one is limited traffic flow confidence. Transport mode provides protection primarily for upper layer protocols. Transport mode protection extends to the payload of an IP address packet. For example, it includes TCP or UDP segment or an ICMP packet, all of which operate directly above Internet Protocol in a host protocol stack. The transport mode is used for end-to-end communication between two hosts, that is, client and server or two workstations. When a host runs AH or ESP over Internet Protocol version 4, the payload is the data that normally follows the IP header. ESP in transport mode encrypts and optionally authenticates the IP payload but not the IP header. AH in transport mode authenticates the IP payload and selected portion of the IP header. Next, we'll discuss the tunnel mode. This tunnel mode will provide some protection to the entire IP packet. To achieve this, H or ESP fields are added to the IP packet. The entire packet plus security fields is treated as the payload of a new outer IP packet with a new outer IP header. Tunnel mode is used when one of or both the ends of a security association or a security gateway, such as a firewall or router, that implements IP security. A number of hosts on network behind firewalls may engage in secure communication without implementing IP security. For example, host A on a network generates an IP packet with the destination address of host B on another network. This packet is routed from the originating host via firewall or secure router at the boundary of A's network. The firewall filters all outgoing packets to determine the need for IP security processing. If this packet from A to B requires IP security, the firewall performs IP security processing and encapsulates the packet with an outlet IP header. The source IP address of this outer IP packet is this firewall, and the destination address may be firewall that forms the boundary to B's local network. This packet is now routed to B's firewall with intermediate routers examining only the outer IP header. At B's firewall, the outer IP header is skipped up and the inner packet is delivered to B. So this table will be summarize the transport and tunnel mode functionality. IP security policy. The fundamental operation of this IP security is the concept of a security policy applied to each IP packet that transits from a source to a destination. IP security policy is determined primarily by the interaction of the two databases, the Security Association database and the Security Policy database. This figure will be illustrate the relevant relationship between these two. Security associations. A key concept that appears in both the authentication and confidentiality mechanisms for IP is the security association. If a peer relationship is needed for two-way secure exchange, then two security associations are required. Security services are afforded to an SA for both use of EH or ESP, but not both. A security association is uniquely identified by three parameters. One is called as a security parameter index. This is a bit string assigned to this SA and having local significance only. The security parameter index is carried in AH and ESP headers to enable the receiving system to select the SA under which a received packet will be processed. IP destination address. This is the address of the destination endpoint of the SA, which may be an end user system or a network system such as a firewall or router. Security protocol identifier. This field from the outer IP header indicates whether the association is an AH or ESP security association. Security association database. Database that defines the parameters associated with each SA. A security association is normally defined by the following parameters. The first one is called as a security parameter index. This is the 32-bit value selected by the receiving end of an SA to uniquely identify the security association. In an SAD entry for an inbound SA, the SPI is used to map traffic to the appropriate security association. Sequence number counter. This is also a 30-bit value used to generate the sequence number field in the EHV or ESP headers. Sequence counter overflow. This is the flag indicating whether the flow of the sequence number counter should generate an auditable event and prevent further transmission of the packets on this security association. Anti-replay window used to determine whether an inbound AH or ESP packet is a replay. AH information, authentication algorithm, keys, key lifetimes, and related parameters being used with AH. ESP information, encryption and authentication algorithm, keys, initialization values, key lifetimes, and related parameters being used with ESP. Lifetime of this security association. A time interval or byte counter after which an SA must be replaced with a new SA or terminated, plus an indication of which these actions should occur. IP protocol mode, tunnel, transport, and wildcard. Path MTU, any observed path maximum transmission unit, and aging variables. Security policy database. This the means by which the IP traffic is related to specific SAs. Each SPD entry is defined by a set of IP and upper layer protocol field values called selectors. So outbound processing obeys the following general sequence for each IP packet. First one is compare the values of the appropriate fields in the package, adjust the SPD to find a matching SPD entry which will point to 0 or more SEs. Determine the SA, if any, for this packet and it's associated with SPI. Do the required IP security processing. The selected determine the NSPD entries. One is called the remote IP address. This is a single IP address and enumerated list or range of addresses or wide called addresses. Local IP address. This may be a single IP address, an enumerated list or range of addresses or wildcard addresses. Next layer, protocol. The IP protocol header, IP version 4, IP version 6 or IP version 6 extension includes a field that designates the protocol operating over Internet Protocol. This is an individual protocol number. Name is a user identifier from the operating system. This is not a field in the IP or upper layer headers, but is available if IP security is running on the same operating system as the user. Local and remote ports. These may be individual TCP or UDP port values, an encounter list of ports, or a wildcard port. This table provides an example of SPD on a host system, and also this table reflects the following configuration. Local network configuration consists of two networks. The basic corporate network configuration has the IP network number 1.2.0/24. The local configuration also includes a secure local area network, often known as a DMZ, that is identified as 1.2.4.0/24. Thank you.